Welcome to another episode of Average Joe's 3D. I'm your host Fergie, and welcome to the Average Joe 3D workshop where all the magic happens. Today we're going to talk about the cube. That's right, the lowly cube. We're going to take the cube, we're going to turn it upside down, sideways, maybe a little crooked, and see what that looks like to print. So sit back, relax, enjoy another episode of Average Joe's 3D. That's right. Nestled amongst all the Batman and weird, creepy, crawly critters and rockets and Benchies and Marvins is our cube. Our lowly little cube right there. And he is definitely the star of the show. There are a lot of times when you're doing a print where you can't do it straight up and down. Now, a good example is the robot here, or Joelbot. Now, Joelbots have these tiny little legs, tiny little arms, and if you have a really good printer, which I do, I have an Ender 2, it's going to print. But you know what? If you don't have that good of a printer, if you're afraid that your hot end is going to knock the print and hurt the legs, you have two options. You can run something called support. These are beams or pillars that run straight up and down off the build plate up to the points to reinforce the Joelbot as he prints, or you can do him sideways. A lot of prints print better lying down or sideways than they do standing up. So today we're going to take a look at taking this cube and printing it at an angle like this. So as you can see with the angled one, I had to get creative. I used something called supports. You can see the supports go from the build plate up to the overhang of more than usually 45 degrees and allows the PLA or plastic to adhere to something. It's just trying to build the bottom side of the cube. Now I have this printed out on something called a raft. That is a base piece of plastic that you use to make the other plastic like supports grab better and hold better, but it's not necessary. A lot of build plates are really great and they can handle all of the support that you need without having to go to the extremes of putting a raft. A raft takes extra plastic and also takes longer to print. What we want to avoid, and what I want to show you to avoid, is too much support. Now this is a modification of my fan for the CR10. And let me zoom in a little bit. This has support here, 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 just about everywhere you can think of. I have a crazy overhang and I need support through the whole thing. The more support you have in a print, the harder it is to remove. So let's take a look at our slicer to see the different settings and where to go to make the settings and how to decide how much of a support you actually need. And it does it. So it generates the supports we need. As you can see, I have that set to any overhang over 50, which the bottom one is. So zoom in a little bit here and you can see that similar to the model I was showing you earlier, this is going to just to the bottom because the sides are a good enough angle that the printer can support printing, stringing them together at a decent resolution that you won't need supports on the top, bottom, or sides. So let's go ahead and take a look at the information you can control in your settings. There we go. Okay, so we go to Edit Process Settings, and there's a tab called Support. Now when you look at the Support tab, let's see if I can zoom in a little bit here. That first one is pretty important. We're going to talk a lot about support infill percentage. Now you got to remember that when it's printing these, these are attached to your print. So the more dense, the more percentage of infill that you have, the more solidly it's attached to your print. And the harder it is to get off. The more of a scar you'll have, or mar, on your print than you would before. The next setting is the the distance. We'll go over that. And we'll also go over the pillar resolution. So that's the three things we're going to look at today. We're going to look at support infill percentage, extra inflation distance, and the support pillar resolution, because the resolution, which is over here, will tell you how thick the pillars are printed, just like you would when you're checking the resolution of your print. You can have like a 0.1 millimeter, 0.2 millimeter, 0.4 millimeter. That's how thick those lines are going to be as I print them, and how much harder it is to remove them. Alright, so I printed out examples of each one, so let's go ahead and take a look at them now. So I printed out 4 of these. Now they're all at a 10% infill because it's easier to see the resolution when you're looking at a 10 than maybe a 60, right? Because they'll be so close together. So this is 1.1 millimeters, 0.2 millimeters, 0.3 millimeters, 0.4 millimeters. So this is the thinnest and this is the thickest. But you know, as you're looking at these, and this is what I discovered when I printed them out, there's not much of a difference. When you go to remove them, the difference between 4 and 1, you can see it if you look really, really close. But from the distance we're looking at now, which is about 3 feet away, I'm not going to see a difference. And so, because normally you're removing the supports with your pliers or maybe with some angle cutters, I think that it'll go through them just fine without you noticing a difference between 1 and 4. They look identical to me. There you go. Not much of a difference. So let's go on to percent, because percent is where it really makes a difference. Okay, so remember our 10, right? This is our 10. Pretty easy to use. Here's a 15. So let's take a look at a 15. Now 15, I'll turn it sideways for you here. There you go. 15 has about twice as many horizontal supports as a 10 does. So let's take a look at a 20. This is a 20. That has even more. I mean, that's quite a bit more than where we started at, which is our 10. So now you're getting really good support. We're still not at the point of no return where you can't remove it from your model without breaking it. And something like a 20 is going to go pretty high. So if you're building something very tall, a 20 will hang in there as it goes up 100, 200, 300, even 400 millimeters. That's not too bad. Let's take a look at a 40. So we're going to double to 40. Now 40 is kind of stretching it. Now 40 is really good if you're going to have something flat, but you can see that now I'm having a hard time seeing the build plate down through it because it's so thick. And where we started out, which is a 10, okay, we're just nowhere close to a 10. Let's take a look at a 60. Now I already took the 60 off the raft, so it's easier to see because the 60 looks like a solid piece. It's not. You can see it's like an accordion, but anything more than 60 and you're not going to be able to remove it very easily at all. Not without a lot of time, patience, and tools. And the tools include X-Acto knives, files, your clippers, and really big needle nose pliers. So on today's show, we've taken a look at how much trouble a small little calibration cube can be. By the way, this is a 20 millimeter calibration cube that I downloaded from Thingiverse. I use it if I want to check for stringing and to make sure it can bridge the gaps where they're supposed to. So this is good to use for troubleshooting. We've taken a look at percentages. How to use your support material, what kind of percentage you should use. The rule of thumb that I use is the higher that the support has to go, the more infill I'm going to need, the bigger the percentage. Because if I'm printing up to, say, 200 millimeters, that support material has to follow the build 200 millimeters all by itself in the middle of nowhere, waiting for an arm or a leg or a nose to support when it gets to the very top. So the higher you're going to go, the bigger the infill. If you're doing something very small, right off the plate, just 10, 15, 30 millimeters off, just use 10%. That should be fine. Well, I hope you enjoyed this episode of Average Joe's 3D. And as always, have a great day.